Okay, so couldn't quite fit it on the last video about blood typing. This is the last blood typing slide, but I would say if you wanted to get some practice for the upcoming quiz for this unit, I would say you could do much worse than to go to the website that you can see, in the third bullet point here. This is probably one of the most useful ways I've ever seen to actually, solidify the concepts behind blood typing. So I would go there, and we're going to go over this in class as well, or maybe even live. I can share the screen with you, and understand how antigens on blood cells, on the red blood cells, are either compatible or incompatible with the antibodies that the body is producing. Remember, antibodies are, produced against foreign proteins or foreign pathogens or anything foreign in the body, as long as it's organic, pretty much. Um, and not only is this going to really highlight the importance of blood typing in a practical aspect, but also, the underlying concepts behind immunity, which I think is a really good thing. All right, so last little bit of this. This is going to be, I believe, the last, installment of blood here. So let's talk about clotting. Okay, so in addition to the defense that your blood provides as far as an immunological context, you have to talk about, or we have to talk about, clotting because blood is precious, right? It distributes things around the body, it regulates heat, it's part of your immune system, and if you lose too much of it, obviously that's not good for your survival. So, clotting is a coordinated series of events to stop the flow, or in other words, the loss of blood out of the body. And I think we've all been here when we were little kids and had skinned up knees, doing something on your bike, on your skateboard, whatever. So what's actually going on there? All right, so we're going to talk about this in the three successive steps: vascular spasm, platelet plug formation, and also coagulation. So you got to think about it. When you get injured, when you scrape your skin, you are breaching or sometimes completely severing blood vessels, right? That means the pressure that is put in your circulatory system by your heart is literally pumping blood, and all that blood tissue is leaving the breach, right? Leaving the cut, the laceration. So upon damage, the blood vessels themselves will constrict. Now, I know it's a little bit, a little bit derived here, but there is smooth muscle lining the vessel walls, right? So within these little, cells and the connective tissue on the outside, there is smooth muscle in the walls of blood vessels. When blood vessels get damaged because of the pain receptors, and a couple other chemicals, which we're going to talk about in a second, the smooth muscle will contract. What that will do is kind of close that open end, or at least reduce the opening, diameter of that open end of the blood vessel, and that'll help to stem the flow of blood. In other words, red cells will start to pile up there, and that'll actually eventually help a clot to form. Okay, so vascular spasm is actually a pretty important thing. If you sever a major blood vessel, God forbid, that's what's going to prevent you from bleeding out right away. Anyway, it'll restrict the flow of blood until you can receive medical attention. So, platelet plug formation, as we said, thrombocytes or platelets are really important for clotting. uh, this is really where they kind of come into play here. So platelets will clump together due to several clotting factors. Okay, and clotting factors in this case are proteins. All right. Now I think that as far as that's where the first letter was black there, but as far as understanding how this works, right? Um, when I say several clotting factors, there are 13 different clotting factors. I am not going to have you guys know every little step here, but basically it's kind of like a biochemical pathway, like we talked about with the endocrine system, right? So you have factor 1 leading to factor 2, all the way down to factor 13. Platelets, with these proteins, okay, will stick tenaciously to the collagen exposed and damaged blood vessels. Now, if you haven't taken ANP1, pardon me, you will probably not know this, but in the walls of vessels and any connective tissue, there is a pretty ubiquitous protein that we make in our bodies called collagen. Okay, it gives our bodies tensile strength in these connective tissues. In other words, it prevents them from being pulled apart. Now, if you think about it, if the pressure inside your blood vessels is kind of high, you would like a nice really strong wrapping of tissue around the blood vessel to make sure that you don't burst a blood vessel, right? Okay, that collagen is really never ever supposed to be exposed to the blood running through it. It's in the outer wall. But when you cut it, right, now you have collagen, this gray stuff that the platelets can recognize and therefore stick to with a protein called factor VIII. This is also called von Willebrand factor. That links platelets together at the plug and to each other and to the collagen in the vessel wall. So it's almost kind of like a glue, right? ADP, so that's adenosine diphosphate, and serotonin, which is basically a hormone, but it also acts as a neurotransmitter, released from the platelets themselves will also increase the platelet aggregation to form a clot. So basically, really what we're saying here, as soon as this collagen is exposed, those platelets that actually touch the collagen will start to secrete proteins that'll lead to more platelets being stuck, right? And then that'll lead to this platelet plug, right? Or what we call the platelet aggregation. So all of these platelets stuck in the hole, obviously, they are the ones that are going to prevent blood loss. Okay. So coagulation is also important. You want a clot to actually kind of tighten up and form a really good plug. You don't want it to be a loose, sort of, I guess you would say more pliable sort of fix, right? So the release of clotting factors changes a protein that is normally in the plasma called prothrombin into thrombin, which is an enzyme. Okay, so now this is activated basically, right, when those clotting factors are released. And remember, there's 13 different ones. I don't think you need to know them. Suffice to say that they're released. If you want to look them up, they're definitely in your textbook, and you can look at every one of those, but that is up to you. Thrombin catalyzes another protein which is present in plasma called fibrinogen. Okay, so now you have the activated enzyme catalyzing a protein normally also in the blood plasma, and that makes fibrin. Fibrin is more like a mesh. I think of it as like a spider web, but then again, I'm biased, right? That collects and captures all the different components of the blood, platelets, red cells, white cells. You can see this white cell kind of like sitting in here, right? Red cells, which that would be one. And there's a whole bunch of other, debris stuck in here, right? Platelets too. And that's what's really going to tighten up the clot. So that fibrin is extremely important. And it's like fibers, right? So it's easy to remember. The clot will then eventually retract into itself. So in other words, it'll start large and kind of get small. So say here's the clot, it'll literally, contract towards its center, and that'll lead to a smaller, more dense clot, right? That is important because, again, it's a better plug, right? And you can see in these little Eppendorf tubes here that, people that don't have those normal proteins, this would be a mutant as far as somebody lacking one of those proteins, their blood doesn't clot, whereas these other three do. And you can see a nice little tight platelet plug there, right? So platelets will also release platelet-derived growth factor, which is interesting. It's kind of like, it's like fertilizer almost for your blood vessels, right? So it stimulates the growth of collagen. Remember, that's the wall of the blood vessel that gives it a lot of strength. And also elastin. Now, elastin is a protein, again, if you didn't take ANP1, that allows tissue to stretch and snap back to its original length again, right? So, you guys are all young, right? If you pull in your skin, pull it out of shape a little bit and let go, it snaps right back into its original, shape, right? Conformation. So that's what elastin does, and that's what will help the blood vessel repair its integrity. So an activated enzyme called plasmin eventually breaks down the fibrin. Remember, that's what's holding everything together in the clot, after being activated by factors derived from the cells that are repaired by platelet-derived growth factors. So what I'm saying here is plasmin is a nice slow breakdown of a clot. If the clot were to break off all of a sudden, and you have this big chunk, say it was interior to the blood vessel, that could be pretty catastrophic, right? You would have a clot literally traveling through your blood vessels, and by the time it got to a narrow point, something smaller than the diameter of the clot, it would stick there. That's going to basically plug up any circulation or disrupt any circulation that would go from that point. So clots breaking free in the body are not a good thing. They can lead to strokes and heart attacks, right? So, all kinds of other problems too. Plasmin has that nice slow breakdown. So, basically the clot dissolves very slowly, and therefore that problem should be avoided. So, that's not to say that people don't suffer from blood clots and can cause problems. If a blood clot does break free, we call that an embolism, right? So, or thrombosis. So, embolisms can, as I said, block blood flow, and that's generally not a good thing. There are multiple drugs on the market. One is called heparin, right? There's also warfarin, aspirin, just regular bare aspirin, inhibits clotting factors. And what that does is prevent big clots from breaking loose and causing problems in the body, right? So if you are bedridden for any length of time, I was on heparin personally. I can tell you that story for a while. I had a spinal cord injury when I was 17 and I was paralyzed from the waist down for about a year. So if I'm not moving my legs, there's a really good chance that blood, which is settling in my blood vessels, could clot, and that's definitely what I don't want. So every morning with my awful hospital breakfast, there was, my eggs and toast or whatever, and my silverware, and a syringe right next to everything, and I had to give myself a shot of heparin in my stomach every morning, which was not very fun for about, I don't know, 4 or 5 months or so. So I'll tell you more about that story later, but it just shows that heparin is extremely important in preventing clots. Okay, last thing. I just want to talk about some genetic bleeding disorders really quick. If you have thrombocytopenia, right, which means the thrombocytes are in a low concentration, that's generally what penia means, it's a lack of, um, that can cause, obviously, bleeding disorders. There are no cellular components that are actually going to cause a clot. So how can this happen? Well, there are genetic problems that can lead to thrombocytopenia. If somebody has a bone marrow problem, right? Because remember, all these cells are made in the bone marrow, in red marrow. That might actually lead to thrombocytopenia. Actually, old age, can lead to thrombocytopenia. There are some people that just don't clot very well. The second one is hemophilia. So, hemophilia is a genetic sex-linked disorder that is passed down, from parents to offspring, right? So, parents to children. It's basically results in low to no production of clotting factors. So, those 13 proteins, one or more of them will not be produced. So, if you break the chain out of all, from protein 1 to 13, clotting is not going to be very good. So if you cut yourself, there's a really good chance that, that could lead to problems. You could bleed out from just a minor cut, right? So how can this be treated? Well, if you think about it, you can donate platelets, right? Or receive platelets if you're suffering from hemophilia. There are, certain ways at the Red Cross that you can just have your platelets strained out of your blood and therefore can be donated to people that have clotting problems, right? Now, that leads obviously to a potential problem because what if that person, and we like to try to screen for these, but what if that donor had a disease and those disease components were in the blood, a long-term disease? People that have, or back in the day when HIV was first being, sort of discovered and worked on and really had a lot of money thrown at it for research, there were people that got HIV, a virus which is way smaller than platelets, in donated blood, and they contracted HIV and eventually died of AIDS, which was obviously not a good thing. So, if I could make one suggestion to you, never get in a situation where you're actually going to have blood donated to you because you never know, right? Screening is supposed to be really good, and most of the time it is, but it's just best to keep your own blood in your own body, of course, right? Last one would be leukemia. So remember, red bone marrow rather, produces all the blood cells. If you have cancer of the bone marrow, that can lead to leukemia. Leukemia means way too many white blood cells, right? And usually these white blood cells are non-functional. If you have leukemia and you're producing cells, way too many white blood cells, they take the place of a proportion of red blood cells, which is why people with leukemia are generally very, very tired and, they have very low energy because they're just not getting the oxygen they need. Okay, so want to end it here. Again, we'll talk about this in more detail when we have some more time meeting as a class. But other than that, this ends the blood unit. So, keep in mind, we will have a quiz. There is a review sheet up on Blackboard. And if you have any questions, we'll talk about it in class. So I'll talk to you later for the next presentation.